Alright, so starting from empty scene, let's create our geometry here. So this will be our HUD, and then we can create a big head just to be subject, and finally a camera. Right, so let's position our camera, and I think we can make it like that. And so let's dive inside the HUD. So the idea here is that we're going to create a plane that fits the camera exactly. And for that we are going to use the from NDC vex function. So NDC stands for normal device coordinate, and this is something that can get you points in screen space, so you can match a grid to exactly the corners of our camera viewport here. So to do that, let's start with a simple grid and let's make it 2 by 2 so we don't have any subdivisions. And what I want to do is to create an attribute wrangle that runs on points. Let's call that from NDC. And I'm also going to split that viewport using alt right bracket, so that gives me 2. And in this one I want to hide everything but our grid, and I also want to turn on the point indices, and then let's view that from a top view. So the goal here is to try and match these numbers to the corners of our camera here. So basically, and let me try and give you a better representation. So basically, point number 0 here, we want to match to this corner using a kind of a normal coordinate. So this is 1 in y and this is 0 in y. The same is this is 0 in x and this is 1 in x. So this is what we're going to do. We're going to match the point numbers to their normal coordinates here. Okay, so let's do that. So I'm going to create an array for that. So let's create a vector, 3D vector array. Let's call that coord for coordinates, and it's an array. And now I'm going to use the append function to add items to this array. So let's add to the coord array, and the value will be and actually let's create some stuff here before. So to convert from a camera space to a 3D space, first thing you need is a camera, right? So let's add a new item to this interface. So let's get a operator path. Let's add to here, and let's call that cam for camera. I'm also going to choose an op filter to be cameras only, and that's good. So now we can pick our camera here. There we go. Now we need to access that inside vex. So it's a string because it's a path, so let's call that cam also, and it's a channel of type string, and the channel name is cam. Right, so this is one thing. The other thing we need to do is to create something that I'm going to call z distance. So z distance is because we're converting from a 2D space into a 3D space, we actually need a depth from the camera that we want to position this grid. So I'm going to call that z dist. So let's create a float channel. So float z dist is equal to channel float, and let's call that z dist. Great. So with that ready, we can proceed to appending items to our array. So the first coordinates we will append is for point number 0. So if you remember, point number 0 is on the upper left corner. So transforming that into a 2D coordinate space, this becomes 0 in x and 1 in y. So that's what we're going to input here. So 0 in x, 1 in y. And the third component of the vector is this, which will be the same for all the points. Okay. So let's do the same for all the 3 other points. So let's copy and paste. So for point ID number 1, we are talking about the upper right corner. So it's 1 in x and 1 in y. So let's do 1 and 1. For point number 2, it's 0, 0. So 0 and 0. And for the last point is 1 and 0. So let's input that here, 1 and 0. Now our array is constructed, what we need to do is just fetching the normal device space and transform that into our 3D space. So to do that, we can use so at p will be the from ndc vex function, which expects two arguments. The first one is from which space you want to transform, and you can use a few strings here, like you can see here, and also you can use a path to a camera, for example. That's what we're going to use. So we can use cam as the camera that we are converting from, and also we give it a position, so a 2D coordinates that will be extracted from that camera, and that will give you as a result the 3D position you want to the grid. So the 2D position will be the actual array item that corresponds to that point index. So we can use chord and use ptnum. Because we have created in order, the ptnum will be exactly what you want for this array index. So let's use that. And one thing I want to do also is, if we visualize the camera here, so let's go back a little bit and let's show our objects. So let's look at our camera here. Sorry, let me go like that. So you can see our point is kind of close to the camera, but it's not really showing, and the reason for that is because we have not created our z distance parameter yet, and that is using a plane that is with distance 0. That means it's exactly at the camera lens. That's not what we want. So let's click that button to create the parameter, and let's up the z distance, and there you go. So you can see the grid growing, and that is following the camera, but this is behind the camera. So we want to do is to actually invert the value. So let's do minus z distance, and there you go. Now we can see that fits exactly our camera view here. And the nice thing about that is that it follows all your camera parameters. So just to check, let's do a camera subdivision so you can see a few lines in here like that. So you see, if I change the angle, it's going to update as soon as I let the mouse go. So there you go, it's back following the position of our camera. And let me turn off the point indices here. So there you go, now it follows nicely my camera, so I can rotate the view and it follows. And it also follows anything I do on the camera itself. So let's say I want to change the resolution, so it will follow, it will squeeze and stretch to follow the new settings. It also works with the focal length, like that. So you see, this is always inside our camera view here. It follows the aperture value also. So yeah, it's bound to the camera. Now what can we do with that? So first let me delete that, and let's also save the scene. So let's call that NDC tutorial. Cool. So what I want to do is to start creating our HUD. So to do that, first I want to calculate the aspect ratio of this grid, because we're going to build a template for a camera plate. So to do that, I'm going to use another attribute wrangle that is going to be called calc aspect ratio. And let's run over detail. So it's only one thing. And so we need to calculate the width and height of this grid. So to do that, very easy. Let me turn on point indices again. So calculate width by subtracting 0.0 from 0.1 and height 0.1 from 0.3. So very, very simple. So let's do that. So float width will be, and because we're running over the detail attribute, we need to use the point function. So point of the input geometry, attribute name is p for position, and the point index is 0. So this minus same thing for 0.1 and we're not interested in the direction but rather in the magnitude of the vector, so we can use the length length function to get the value. And now Vex is going to complain because when you use the point function, Vex actually doesn't know what the result of it is, so you need to cast your value to the proper type. So in this case, this is a vector. I know this is a vector, so I want to cast that to vector. So you can do vector and put everything into parentheses, and now it works. So let's do the same for the height. So height is 0.1 to 0.3. It doesn't matter the order, you can do 1 to 3 or 3 to 1, because they're just measuring the distance between the two vectors, and we don't want the direction, then it doesn't matter. So because we already have 1 here, I'm going to put 3, and there you go. Now we have, sorry, let's call that correct name, and now we have width and height, and to get the aspect ratio we just need to divide one by the other. Now, because I want to always use my width as the base value and get the height to be the proportional value, I'm going to use height divided by width. So let's create an attribute and call that, so let's call it aspect. And that's going to be height divided by width. Okay. So let's check if this is working. So let me get a new geometry spreadsheet here. Let's change to detail, and there you go, 0.56. Now if we do the inverse, so let's do the inverse, then you're gonna get the the usual 1.77 value, which is the HD aspect, which is what we're going to use now. If we use a square camera, that's going to be always 1, so let's change that to 100 by 100, and there you go. Now I have aspect of 1, but let's go with the defaults here, and let's go back with our width based aspect ratio. Now, good. So here I want to start working on my HUD elements. So what I want to do is to create a template for this grid that it stays at the origin, and it serves as a way for me to lay out my elements. So what we're going to do is to create a new grid, and what we want to do is to set the size to exactly, or not exactly the values, but following the aspect ratio. So let's say I want the X size to be 1, and like the width and the height, I want to be a proportional value using the aspect ratio we get from here. So to do that, we can create multiple ways to do that. You could either use a detail function and query the attribute from here, but I prefer to let's go back to the full values here. So I prefer to just use a spare input. I think it's easier, and it makes the expressions smaller. So just drag and drop the node here. It's going to create a connection line. So now you can use the detail function and use -1 instead of the path. So the attribute you want to get is the aspect, and the full value is 0. And there you go. Now we have 1 by 0.56, and it stays at the base. So let's visualize that. Now let's also hide our other objects. And there you go. Now we have this thing that stays at the origin, and it matches the aspect ratio of our HUD grid. Okay, so what we can do is use that as a base for layouting our information. So let's also put 2 by 2 so I don't have anything in the way. Now let's say we want to add the current frame to our camera plate here. So we can use a font swap, add the frame, let's say 4 padding, and now there you go. So what we want to do is to lay out our elements inside that grid using the top view. So let's go into the top view here and frame. So I want to rotate that minus 90 degrees, and let's scale the font a little bit so it fits nicely. So let's do a small thing here at the corner. So let's align that, or we don't need to align, you can just position the way you like. So let's go in here, and what I want to do is also change the level of detail, because this is actual geometry, so it can get quite heavy. So it's always a good idea if you like just check your points, your point numbers here. So you can see you have a lot of points. I found that 0.1 is something that gives us a pretty decent result without impacting the overall performance. So let's go with fewer points, and now let's color that like black. Probably let's go with darker color so we can actually see, and it's good. Now let's move that, like we need to move all our elements to match our plate grid. So we can do that by using the extract transforms node. So let's first create a placeholder for our layout here. So let's use a merge, because I want to add other elements to that. And let's create a node here. So this will be our HUD info. Let's color that black. Good. And so what I want to do is to use extract transforms node. So let's extract using that grid as a base. So the grid that stays at the origin as a base, and the grid that is transformed to the camera as our reference as our target geometry. So what that will do is to create a single point which has a set of attributes that can transform our elements that are lying inside this region here. So we also want to go and turn on the uniform scale, and now there you go. So we can use the transform pieces node to transform our HUD info using that transform attributes, and there you go. Now you can see we have our frame here, and if you play we get that updating. So that's very cool. Now it's just a matter of creating more stuff into this layout. So let's say we want to maybe use this HUD to visualize the UVs of an object. So if our object has UVs, for example, let's see if that test geometry has UVs by default. I think it does. So does it add shader? Probably, yeah. There you go. So we have UVs. So let's go back to that, and what we can do is to import the object. So object merge, let's bring in the pig head here. So let's go to test geometry into this object, and what I want to do is to make use of the labs UV visualize node to use it to view in world space. And I want to visualize islands, and let's get a smaller grid, and also yeah, I think that's good enough. So what I want to do now is to try and position that inside my layout area here. So we can do a transform to rotate that 90 degrees, so it's at the ground. And then we can use that to transform inside our HUD here. So let's put that on the upper right corner. So let's transform that in here. So there you go. Now this is very cool, because you can just add to the merged geometry. And let's again visualize our HUD here. So let's go back to camera. There you go. So what we can do is just add elements. So there you go. Now we're seeing the transformed UVs. So it's super cool. Just one thing, this is set, like the color of this font is set to as a point attribute, while this one is set as a primitive attribute. and that's the reason why you're not seeing the island colors here. So what you can do is an attribute promote, just to make the colors go from primitive to point, and then we can see that in the viewport also. So there you go. Now if we change the inputs here, so let's say instead of using the pig, let's use something else here. So let's say we have a torus, and let's do a UV flatten, just so that we have the UVs. And I'm going to use, and you can see right away the UVs here. So let's say I want to add some seams like here and here, and let's do a UV layout, and there you go. Now it's the HUD is showing the new UVs. So right away I see I need to reposition that better. So let's go back to here, and let's position that better into the correct place. And there you go. Now we can visualize it again. So you can see we can switch between the pig head, and let's ping that viewport. So you can switch between the pig head and the torus, and then you can see both working. So that's very cool. We have a on-camera UV checker, which is very nice. So now you can add all the information you want. So this is the power of this system. So let's say, for example, and this is a very nice trick with dictionaries, something that is newly added to Houdini 18.5. So let's say you are debugging like a simulation or whatever. Let's say we have a pyro solver here. So we have a pyro solver. Let's say our object is emitting smoke or whatever. So I'll do something super simple here. Let's say we have a VDB from polygons, and voxel size is very big because I don't want to spend time setting this up. Voxel size is also big here, so we're going to source density, and that's good. We're not interested in the simulation itself, just on the parameters. So now let's say you want to debug like everything related to dissipation. So we have a dissipation value here, you have a dissipation tab with a few values here. So how can you check that? So if you want to add those this information to your camera plate, you can again use a font swap, and let's set our detail to 0.1, and let's rotate -90 so it stays at the ground, so you can visualize that. Probably want to do a small thing here. Let's also color that black, and let's position so let's do alignment left and top, and let's position that at the top left corner and make that thing smaller. So let's go back in here, and I want to change the scale using the font size. So let's go with very small value because that thing is going to grow. So there you go. Now we have something at the top right top left corner. So what we want to do is inside that font swap, I'm going to read a few parameters from this pyro solver and display them on the HUD. So I'm going to use this very nice node called attribute from parameters, this one, which creates a dictionary out of parameters and stores that as an attribute. So we can visualize that by going to the spreadsheet. So let's say the node path is, you can either select from here, but because I want to use with it's connected to that node, I'm going to use an expression. So backticks, and then we're going to use op input path, and so we're going to use the current input number 0. So there you go. And if we hit enter, we can choose the category filter, which parameters we're going to fetch. In that case, we're fetching a whole lot of parameters, like the whole thing. So you can see we have a params attribute, which is of type dictionary, and is that much of information. So let's let's make it that much less info. So we only are interested in the, like, say, dissipation attributes. So we can use a wildcard here. So let's say dissipation, and now we have much less stuff going on here. So let's see if sorry, I'm misspelling the thing. Dissipation, is that correct? Attribute, oh sorry, form, it's not in here, it's on the parameter filter. So dissipation, and there you go. Now we have less information, as you can see. So what we can do now is read those attribute values from the font SOP using a Python expression. So let's alt click the parameter to create a keyframe here, and let's change that to change expression to Python. And let's do Alt E to open the editor, and let's create something here. So first, the current node is who.pwd. So this is giving us our current font SOP. Then the geometry I want to work on is actually the geometry from this node here. So what I want to do is to again create a spare input. So let's add a spare input, and let's drag and drop this node in here. So to access that node, we can use node.parm, and this parm is called spare input 0. So let's call that spare input 0. So we can use the eval as node to evaluate that as an Houdini object, Houdini node object. And now we want to access the geometry of that node, because we are going to fetch some attributes. So let's call that geo. So geo is that node dot geometry. Okay, so to get this attribute specifically, we can use parms will be geo.attrib_vol. So that's going to query an attribute at the detail class, and the attribute name is also parms. So we can verify that this is working by returning a string representation of the parms variable, and this will give him an error. Let's see what's going on here. Sorry, I think it's attribute value instead. Geo attribute value, maybe camel case. There you go. So now we are getting all the values from that dictionary. So it's already converting into a Python dictionary. So we are now going to loop over the dictionary keys and values and create a better formatting for displaying our values. So let's do a let's create a string. So let's call that string return. So this is what we're going to return at the end of the code here. So we're going to do a dictionary for loop here. So for key and value in parms.items. So let's say we want to print so our string return will be incremented with let's do a formatting here. So the value, or sorry, the key and the value. So %s for placeholders for the values, and then % and a tuple with the actual values. So let's say, and also, sorry, I need a new line after everything. So let's say when key and value, and that's basically it. Now we can return that. So return this variable here. So if we apply, we can see we get the whole thing displayed here. So I'll just change one thing if the parm is a tuple, just because I don't want that like large value to show on screen. I'll just add a warning that this is a tuple and I'm not going to show anything. So we can do v if not is instance v and tuple. Otherwise, we're going to show just a text called tuple, like so. And there you go. If it's a tuple, we know it's a tuple, but we are not going to show that, and that's makes it easier on the viewport. Okay, so there you go. Now our text is ready. We just need to add that to the merge, so we can just plug that into the merge. And if we visualize that HUD, there you go, we have all our dissipation related attributes in the viewport, which will eventually update if we have changing values in here. But because I just want to read that once, I'm going to also use a time shift here, so that's easier to has more performance. And there you go. Now, one thing I find interesting is that, and I'm having something wrong here. And well, the reason why is because I need to actually plug that before, because I'm using this thing to read parameters. So in here, instead of the attribute from parm, I want to read the time shift, and there you go. Now, two things. First, I want that to be much smaller on screen, so let's go to the font size and lower that a little bit more, like that maybe. Second, I want to have that thing all properly spaced, so it's just a bit more of Python, but it's always good to know this. So for the key, I want to use the rjust function for justifying, and let's use, I don't know how many characters. Actually, you know what, let's do something dynamic. So I want to get the key in this dictionary that has the that is the more length, and then use that as my max value for justifying. So what I can do is use a variable called max length, and that's going to be max function, and we need to use a list as a argument. So the list is length of item for item in parms dot keys. So we're going to read all the key names. Sorry, keys. So read all the key names and get the length of that string, and then we are maxing that value to get the max length. And we are going to use the max length as the number of characters for the rjustify function here. So if we apply, we're going to get an error. Sorry, it's a typo. Or just there you go, which creates this. It is working, but problem is this font has different pixel values for each character, so we probably need a mono spaced font. And one that I know is the Courier. Is not the beautiest font, but it's something that works for us. So Courier, and there you go. Now we have values very nicely layouted on the screen. So what we can do is try other parameters. So let's say we want to have everything related to disturbance. And now there you go, everything related to disturbance is on the screen. You can very quick create debugging shots or debugging plates for your objects, and at any time you can reposition. So let's say, well, I want to position that in other places, so you can go to your font swap. Let's actually turn on show current operator, and now we can maybe put that on the bottom here or on the top, or you can choose where you can put that information. And this is very nice. So now you can see how we can build this very rich heads-up displays. And the nice thing is your camera always have this, so you can rotate. As soon as you let go of the mouse, it's going to get the new information again. And I found this a very interesting way. And if you go very low with our font details, that will not impact your performance. So you can play, and it's playing at around 20 something frames per second. I think that performance hit is because of the power solver. Is it? I don't think so. We'll have the time shift. But yes, I know that the font level of detail, it plays like a role in this performance hit. So we can even try and change that to something maybe less, a little bit, something like this. And you can see now we are getting the 24 frames per second. Now you see it starts giving us like very bad results, but you know, as always, it's a trade-off between performance and amount of geometry. But yeah, because if you are doing like flipbooks and you don't need to be real time, you can add a whole lot of information in here, which is great. And if you want to, just let me change to the perspective here. So let's show our objects. So you can see our plate is at that distance from the camera. If your object is very close to the camera, you might want to move that grid towards your camera even more. So you can go to a HUD and change the Z distance, so you can start lowering that value. And you can see it has no effect on the screen, just on the 3D space. And there will be sometimes that you're going to lose the values, and that's only because of your camera clipping planes. If you lower your near clipping plane, you start to see your HUD again. So there you go. And now it's very close to camera. You won't have any troubles of it intersecting with your actual geometry, and that's super cool. So you can come up with a lot of stuff to do here. Just one more hint, one more tip for you. There's one other cool thing you can do, which is to use textures from a COP network. So let's go back to our HUD here. So let's create a COP network. Now this can start to become a bit more heavy on the performance side. So let's say you want to check the silhouette of your object. So what you can do is to use a COPNet and use a geometry node. So let's bring in a SOP. So our SOP is our pig head, which is not a pig head anymore, but anyway, there you go. Now if we go to our viewer composite view here, let's check this. So the image, let's override our size. Let's do a very small image so it doesn't suffer too much about the performance. So let's go with 200, and the actual Y value needs to be taken from your HUD aspect ratio. So we can do, so let's create a node here that hosts the aspect ratio for us. So let's call that aspect. I'm going to create a new float parameter here. So let's go to float. Let's call that also aspect. Accept. And we can do a adds per input. Let's ping the parameter and let's drag and drop our calc aspect ratio, and we'll do the same. So let's do a detail -1 aspect and 0. There you go. Gets our aspect ratio. Now you can just copy parameter. Let's go back to our HUD here, or sorry, to our COP network. And then in here we can do paste the relative references and multiply that by the width, like so. And there you go. Now we are generating the image at the same aspect ratio using some value for the height. So there you go. It is taking the silhouette from this object. Now we can view. Unfortunately, there is no way you can view from a camera. So actually, you know what? We don't need this because we're not viewing from the camera. We can use any resolution we like. So let's say we want a square resolution. Let's say 500 by 500, and we get this. Let's say we want to view from a top view, so y-axis. There you go. So this is our silhouette. So we can use that in our HUD. And the way we can use that, let's create another node here. Let's call that alt. I'm going to Ctrl C on that node, and let's create a grid. Now this grid is going to be on the ground again, horizontal. Let's do 2 by 2, and let's make it much smaller. And we actually want that to fit our layout here. So let's again look for it using the orthographic view. So let's uncheck other objects, and what I want to do is to fit our plane, our grid inside the HUD. So let's visualize that together with everything else. So we can do a real-time layout here. So we want to enable current operator, and now let's say, or actually let's put in a transform node. I think it's easier. All right, so let's put that in here. So this will be our layout. And now I want to actually fetch the image from this CopNet. So how can we do that? Trick here, you can use a material network. Let's create a material builder. We are not going to actually build anything, but rather we're going to use that as a placeholder for our OpenGL tags. So let's call that whatever, material. And let's add a material node in the grid, and we want to go and get that material from that material network. So now inside here you can go to your MatNet, open the parameters, and let's start hiding by hiding those two that we're not interested in. So what we want to do is to add a file image attribute parameter, and let's call that texture. The name doesn't matter really, it's just for organization. So what makes it show on the viewport as texture is a OpenGL tag. So you can use the built-in tags, and now you have a whole lot of OpenGL tags that you can use. Let me clear the filter here. So there you go. Now you can see you have a lot of stuff you can change on the viewport. So we are actually interested in the diffuse texture. So let's use this texture tag here. Let's accept. And if you have that tag on your parameter, then any texture you input into here will be used to show on the OpenGL screen. So let's test that. So let's use something from Houdini. So I'm in the Houdini file system here using some sample textures. So this is a grid, sorry, this is a brick, and I'm assigning that material. Is it assigned? Sorry, let me check here. It is assigned. Is this using the correct tag? OpenGL tags. Let me accept. And I guess to update textures maybe. Oh yeah, of course we don't have any UVs. It's not going to show. So let's create quickly some UVs here. So let's do a UV texture. There we go. Now we have the textures going on here. So nice trick. Let's use the silhouette we have created in cops. So we can go to our material builder, and instead of pointing that to a texture on disk, we're going to use a live reference for that operator. That is why Houdini is so powerful. So let's use the op syntax. So op will evaluate an operator live and get the result and use that as a texture. So I'm going to Control V the path to that cop node, and there you go. Now we are seeing the silhouette from above. So if we ever go to our test geometry here, and let's maximize this thing here. So if we ever go to our test geometry and start rotating that, so let's do a rotation, a transform, and if we start rotating in X, so let's do $F. So now if we play, you see this thing is going to be updated, but this is unfortunately not real time, because Houdini has a caching system for the textures, for the materials. It's only going to update if you do update textures, and now it's updated. So let's go a bit forward, then update textures. It's now updated. But if we're going to render that through a OpenGL ROP, then it's going to work. So yeah, that's another nice trick that I'm using for maybe if you're just modeling and you want to get some reference on screen, you can just add that to your camera plate, and then you can start modeling. Of course, what we did here is like too intrusive. We have tons of stuff in here that we don't actually need. But yeah, now we can just put that into an HDA, so that part here, and this is your layout. So you can build a lot of templates for your files. So this is a layout which I can call UVs plus whatever attributes, and you can create another layout for just simulation, and you can create another one for just animation, and you can see from other angles and that sort of stuff. So this is very powerful. Lots of stuff you can do with normal device coordinates. So yeah, I hope you liked this one. Probably one more video with NDC functions, where I'm going to try and do a nice screen space based geometry deformation. So yeah, that's for the next video. So hope you like this one, and until the next one, take care and goodbye.